Hi. Okay. For this session, we're going to prove that the normal PDF is a PDF, meaning it integrates to one. Okay. So to start, we say that we have a normal distribution X with mean of mu and standard deviation sigma. Okay. So what we wish to do is we wish to prove that the integral of f of x dx, which is the PDF of the normal, evaluated from negative infinity to positive infinity, is equal to 1. Okay, so now here f of x would be equal to 1 over square root of 2 pi sigma e to the negative half x minus mu sigma squared. Okay, so we let z equal to x minus mu over sigma. Okay, so this is a standard normal. Okay, so we are going to make this substitution here, and so from here we say that z is equal to dx all over sigma, dz is equal to dx over sigma. And so what we have is the integral of f of x dx, and let's just put it in now. Okay, the integral of 1 all over square root of 2 pi sigma e to the negative half x minus mu divided by sigma squared dx. Okay, notice that this part here is your dz and this part here is just your z. Okay, so this thing can be written as integral of 1 over square root of 2 pi e to the negative half z square dz. Okay, now notice that when x is going to infinity, z is also going to infinity. When x is negative infinity, z also goes to negative infinity. Yeah, so here we let this equal to a, right? And then we say that a square, we just square this one here. Okay, so we can take this one out. We say 1 over 2 pi. Now we'll have it as double integral instead now. Okay, this will be double integral of e to the negative half. Okay, e to the negative half of, say, z square plus y square. Okay, dy dz. Okay, so we're going to let y go from negative infinity to infinity, and we go let z from negative infinity to infinity. Now, if this is not obvious to you why this should be true, note that when I integrate this with respect to y, this is going to be z is going to be a constant, right? Okay, z is going to be a constant. It can go out of the expectation of the integral, right? And okay, so let's see here. Why? Because this thing here is just, I can get the z out of the expectation. E to the negative half z square integral of e to the negative half y square dy from negative infinity to infinity, right? Easy. Note that this is just again equal to a, right? And now the integral, this one, this is a constant, so I can take it out, right? So I can take it out of the integral, and what is left is this thing, which is also an a, right? And so we see that this is just simply equal to a squared, right? So we're not gonna be dealing with that. We're just showing that it should be true. Okay, so now, right? So now what we're going to do is we're going to make a trigonometric substitution. Let's just say this is my z and this is my y. Okay, pick any point here. This has you have r theta. Okay, So we're going to let z equal the coordinate of point here of this point here would be z equals r cosine theta, and y is equal to r sine theta. Okay, now here your a square would be 1 over 2 pi, the double integral. I'm gonna drop the limits first. Okay, so integral, double integral, the double integral of e to the negative half. Okay, now here z square plus y square, right? So z square plus y square is obvious. It is obvious that it is just equal to r squared. Yeah, right, because it's gonna be r square cosine theta plus r square sine theta. Okay, and cosine square theta plus sine square theta is equal to 1. So this is just 1. Okay, so z square plus y square is just 1. Okay, so I'm just gonna put this as integral of negative half r square. Okay, now what do we do with dy dz? Okay, we're going to replace this with the Jacobian. Okay, dr d theta. Okay, and what's this Jacobian here? This is going to be partial of u with respect to, that's not partial of u, we're using r and c, partial of z with respect to theta, okay, with respect to r, partial of z with respect to theta, partial of y with respect to r, partial of y with respect to theta. Okay, right? And here, what's partial of r with respect, what's partial of z with respect to r? What's the Jacobian here? Partial of z with respect to r would be cosine theta, right? Partial of z with respect to theta would be negative r sine theta. Partial of y with respect to r would be sine theta, and partial of y with respect to theta would be r cosine theta. Okay, and then you do the multiplication here. This would be r cosine square theta minus, okay, minus that will be plus r sine squared theta, and again this is just equal to r, right? So we're saying here that a square will be 1 over 2 pi, the double integral of e to the negative half 1/2 r squared r dr d theta. Okay, yeah, so it should be clear that this I can integrate now by letting, say, I'm gonna let u to be equal to half r square, then du would be equal to negative r dr, right? Okay, right, so here this is going to be my du and this is going to be my u, right? And so, okay, we haven't fixed the limit of integration here. Okay, so as you can see here, r goes from 0 to 2 pi, right? 0 to 2 pi, and your theta 0 to infinity, and theta goes from 0 to 2 pi. Okay, so we can actually invert this, okay, because we want to we can keep it like that. Okay, so the inner integral here which is evaluated from 0